This is Pet Life Radio. Let's talk pets.
Welcome to Aquariumania. I'm your host, Dr. Roy Anong, speaking to you from the University of Florida's Tropical Aquaculture Laboratory. Thanks for joining us. Clownfish, the first marine aquarium fish in commercial production, have been a staple of the industry for decades. Soon, the thirst for designer clownfish took hold, and just like with koi, goldfish, and freshwater angelfish, an explosion of varieties has now occurred. My guest today is Matt Peterson, hobbyist for over 33 years and senior editor and associate publisher with Reef to Rainforest Media, LLC. Matt is intimately involved with Coral and Amazonas magazines, as well as their online presence at reef2rainforest.com. Matt started the Marine Ornamental Fish and Invertebrate Breeders Association, sits on the Marine Breeders Initiative Council, and was 2009 Aquarist of the Year by IMAC West and MASNA. Join us as Matt discusses the past, present, and future of clownfish varieties. We'll be right back after these messages.
Put on a perfectly possum pet party. Having an awesome birthday or adoption day celebration for your four-legged friend? Or just want a fun excuse to throw a fun party with your friends from the dog park? Deck out your party with Molly and Bandit Pet Party accessories. Party products designed specifically for pets. There are wearables, including adjustable pet party hats, bow ties, and tutus. The photo prop kits include funny glasses and hats. The party supplies and decorations include coordinating table covers, party banners, cake decorations, and treat bowls, cups, and bags. Everything you need to create great memories and Instagram-worthy photos. They're available in two colorful themes, tropical and fireman. It's a dog's life. Celebrate it with Molly and Bandit Pet Party at mollyandbanditpetparty.com/petlife.
Let's Talk Pets on PetLifeRadio.com.
We're back and continuing our conversation with my guest, Matt Peterson, on clownfish varieties, genetics, and hybrids. So let's talk a little bit about breeding, Matt.
Okay.
Can you explain some of the interesting details about clownfish reproduction and gender determination? I think that's something some of our folks may have no idea about.
Well, clownfish are sequential hermaphrodites. They start their life out as a male. They're all born male, basically. They lack the actual chromosomes, supposedly, that differentiate sex. So they're born as a male, and basically social pressure keeps them a male until they are the largest and most dominant fish in the group, at which point they turn into the female. So if you look at a picture of clownfishes in an anemone in the wild, the largest fish in that anemone, that's going to be the functional female. She's going to be the one that's laying all the eggs. The next largest fish in the anemone is going to be her male, her mate. And all the other fish that are around that are smaller are going to be, generally speaking, sexually inactive males. And they're waiting for their chance to move up the chain to either become the sexually functional male or to become the sexually functional female. So a lot of people have noted over the years that if Nemo was biologically accurate, Marlin would have become Marlena and Nemo would have been having sex with his dad. That's how it would work in the clownfish world. So as far as their actual reproduction and their reproductive strategies, they're demersal spawners. They lay a nest on a hard substrate and they do practice brood care of that nest. And then depending on the species, the eggs hatch out anywhere from 6 days to 11 days later. And once they hatch, they travel up into the water column as pelagic larvae, and they float around in the plankton for a week to 2 weeks in general before finding a reef, settling out on that reef, and metamorphosizing into a juvenile clownfish. So that's the very short life history of a clownfish.
Well, thanks very much. That was very graphic. So you've written a number of excellent articles, especially in Coral Magazine, and you admit kind of this inner debate early on over pros and cons of, essentially these purposeful production of clownfish patterns and finnage variations. Can you explain your initial thoughts on this subject and what your feelings are now on this kind of domestication of the clownfish?
Okay, so I'm going to go back to 2006. I'm pretty sure that's when I said it. At one point, I looked at this fish we call the Picasso percula. And for the listeners who don't know what that is, if you imagine a regular three-striped Nemo type clownfish, but take its barring, the striping that it has, make it wavy and curly, and then maybe it connects with the other stripes. It just doesn't look like bars. It has a more abstract artistic pattern to it. That's the Picasso percula. And I used to say that the Picasso percula was going to be the death of the three-barred clownfish. And what I meant by that was that everyone would want to buy Picasso perculas, and because that's what everyone would buy, all the breeders would stop producing the regular wild type natural three-striped clownfish. So I have a big conservation-oriented streak in my breeding and just in my philosophy, and it comes from, more than anything else, my time rearing and selling African cichlids. One of my favorite examples was a time, now we're going back 20 years, I walked into a house from a breeder who was trying to sell our company several species of peacocks, a lunicara. And for those that don't know, the juveniles and the females are drably colored. They all basically look the same. It would be really, really difficult to even try to hedge a guess as to what species a juvenile peacock is just by looking at it. So I went to this breeder's house, and I'm like, okay, I'm here to see the peacocks. And he says, well, here they all are. And they're all in one tank. And, his broodstock's all in one tank. And I said, well, what do you mean this is it? This is this. All these fish in this 75-gallon tank, maybe 7 or 8 varieties of peacocks, would all be freely hybridizing with each other. The females would mate with whatever most aggressive male was there. There would be no way to tell which female was holding the eggs anyways, and no way to tell what the babies were. And that's just horrible. That's just a terrible mess, because when you're trying to sell something as a particular species and variety of peacock, the last thing you want is to sell it to someone as something, and then it turns out to be something completely different. That ruins all the work that the person puts into rearing that fish. It ruins your reputation because they're angry with you. It's just not a good thing. And then you throw in the concern over the Victorian haplochromine, which many of them have gone extinct. They may only be in the aquarium hobby at this point. And you realize that what we do as breeders really makes a big difference in the future of a species. So the thought of losing the three-striped wild type natural clownfish that we all grew up knowing and loving, for me, that's just unacceptable. So because I looked at it and said, everyone loves these Picasso perculas, everyone wants these fish, I was genuinely concerned that we would lose our natural species in the trade and our natural varieties in the trade. So that was my viewpoint almost 9 years ago now. Since that time, I came to learn a number of things I didn't know. And knowledge always should change your viewpoint and your mindset. And one of the first things I came to find out is that something like the Picasso percula in particular, this was not something that showed up in someone's tank. The original Picasso percula was a wild-caught fish, and since that time there have been several examples of additional Picasso perculas that have been caught in the wild. So it's part of the natural biodiversity. And if you're going to be honest about having a conservation ethic, something that occurs in nature is something that's worth preserving. So that kind of put a chink in my argument that these things are intrinsically and inherently bad at all costs. Then I came to find out that Picasso is just a mutant gene. And I'm going to liken that, just for simplicity's sake at this point, to something like albinism. It's a gene in the fish. Everything else is the same, and one gene is changing the appearance of that fish. You can control for that gene, and you can breed that gene out. And it turns out that if you're breeding Picasso perculas, you're breeding to produce Picasso perculas, there are always some wild-type three-striped regular old percula clownfish in the offspring, in most cases. So all of a sudden, it came to realize there will always be these wild-type percula clownfish. So this notion that this designer fish, this single gene, was somehow going to be a huge problem from the standpoint of conserving the wild-type fish just completely fell away. And if that's no longer a concern of mine, then I don't really have to have a problem with it. And, I can't say don't do it, because it's not really the problem I thought it would be. So that's how my opinion on genetics has changed. When it comes to hybrids, that's a far different story, because once something is a hybrid, you can never undo that. So all the people who are mating perculas with ocellaris, for example, once those two species are blended together, you can never get perculas or ocellaris back out. So from a conservation standpoint, hybrids represent a much more problematic thing that's occurring in the hobby. When it comes to Picassos and Proculas and Ocellaris being hybridized, that's happening. That's going to continue to happen. The same thing with the Ocellaris and the Darwin Ocellaris, which is the black Ocellaris. Those have been very freely hybridized, and some people pass that decision to do it off on the basis that, well, currently they're both considered the same species, so we're not hybridizing. That's not really true. And I like to point back to that Barbari example I pulled up in the beginning and say, I could have used that same argument some 10 years ago to take Barbari from Fiji and Melanopus from the Solomons and say, oh, well, right now they're both considered Melanopus. It's okay to mix these two fish together. You will never get Barbari or Melanopus from the Solomons back out of those offspring. You can't undo that. And to take this to a very extreme final conclusion, let's hypothetically say that something horrible happens in Fiji and all of a sudden Amphiporium barbari is, but we might still have it in the aquarium industry. Any scientist working on any sort of species management or species reintroduction type project, those fish become unusable, completely unusable for any of those programs. So that goes back to having that conservation ethic and being a better steward of the animals we keep and breed in captivity, because you never know when what we do as breeders is either going to really bring something positive about or really screw something up. So hybridization is a different animal for me, it's a different beast, it's a different problem. It's not something we have to completely avoid, but we have to be very careful about the choices we make. And the conclusion I've come to when it comes to hybrids is the only hybrids that are really acceptable are those which we know are going to be readily identifiable as a hybrid and not be confused with anything else that currently exists.
So, hey, let's talk a little bit then about some of these variations. And for example, can you explain to our listeners what a snowflake is, black ice, lightning, some of these other variants, what their appearance is, and maybe real briefly what your knowledge is of how they come about?
Okay, so that's a great one to ask, and I'll stick strictly with the snowflake and the Ocellaris as a species, because I like to say it is the most guppified species of clownfish at this time. So snowflake is a single mutant gene that modifies the appearance of a regular orange clownfish, and what it does is it acts a lot like that Picasso gene I was talking about. It modifies the appearance of the stripes. So basically the edges of the stripes become more crinkly. They're not straight. They kind of bump in and out, so they get very squiggly. The shape of the stripe changes. A lot of times it's more like a patch or a blotch. And that's on all the stripes. Sometimes in the most extreme examples, the fish can be almost solid white, but again, still having these crinkly edges. There may be some black spotting in the white areas because basically that's actually a bar edge that's appeared in the middle of the stripe. So snowflake was discovered by Tropica Marine Center in the UK. My understanding is that they might have had about 100 fish randomly show up over the years out of a pair of regular Ocellaris. It's a mutation that occurred in captivity, and they capitalized on it. The gene, it's a single gene, and as far as we know, it's a dominant gene, which means if the fish has the gene, it shows up in its full expression. So if you take a snowflake Ocellaris and made it to a regular wild type free-barred Ocellaris, you get 50% snowflake Ocellaris and 50% regular three-striped Ocellaris. An interesting side note, no one has proven the existence of what we would call a homozygous or double dose snowflake Ocellaris, a fish that has two copies of that gene on the locus. So mating snowflake to snowflake, you might assume you would get potentially over generations 100% snowflake out of the offspring, but you never actually do. And you get a little more snowflakes, you might get some variations or some intensification in the patterning, or you might go the other direction and kind of lose some of that uniqueness because of the other genetics that you can't easily understand that are interplaying with that stripe altering gene. But at the end of the day, snowflake is a single dominant gene, probably fatal or otherwise doesn't show up in a double dose. That's how snowflake works. But there are other genes as well in Ocellaris. We have things like albinism, which is well understood. We have a wide bar gene, which is not understood at this point. At least I don't have enough information to talk about it. We have a longfin gene that just showed up. And yes, I'm talking longfin like a veil-tail guppy, a longfin beta, a veil angelfish, a Ocellaris clownfish with long fins. And unfortunately, the fins don't have the flowy nature that something like a veil angelfish has. The fins on a longfin Ocellaris appear kind of rigid, and the edging is all kind of ragged and spiky. So some people really like them and think they're really cool, and other people really dislike them. And that tends to be something we hear when we start to look at the more guppified ornamental fishes, whether we're talking about longfin rams or all the ornamental goldfish, even something as relatively benign as a butterfly koi. There are people who view these genetic mutations as aberrations and being problems, and that's a debate. That's a separate debate. At the end of the day, these are all genes that can be bred out and controlled for, and you can turn the fish back as a population to a wild fish if you ever needed to. Another gene that's really dominant in the Ocellaris clownfish is this gene called, I've come to call it the Da Vinci gene. It goes by a few different names, but Da Vinci is the one that isn't really being used for anything else. So that seems to be the best one to use. And the Da Vinci gene is responsible for Da Vinci, gladiator, and fancy white clownfish. What the Da Vinci gene does is basically, again, it's a stripe modifying gene. So it causes the stripes to bar off and swirl, and sometimes some spots will appear. It doesn't make them jagged, however. The edges of the bars are still very smooth. You'll get fish that have what some people call a helmet, where there's more of a white patch on the head stripe that covers more of the head. Some of the fish get what we call mutton chops, where there's this extra little white on the cheeks. And there's a lot of variation within how that gene expresses itself. So some fish have very little patterning changed, and some fish are very extremely patterned, where, for example, some of the best fish and the most desirable and expensive fish, this is just an aesthetic-based desire, might have all 6 of the bars on the fish, but will be connected with some extra striping that occurs maybe along the back or along the flank. So they get kind of really looking different from a wild type Ocellaris. And that's when you just have one copy of the gene inherited in the fish. If you get 2 copies of the gene, so if you get one from the mother and one from the father, you get what we all know as a Wyoming white, a solid white clownfish with basically black and orange fins. That's the double dose, the homozygous form of the Da Vinci gene. So the Da Vinci gene is what we call a partially dominant gene, which basically, to summarize, says you get 1 copy, you get a certain amount of alteration. You get 2 copies, you get more or something different when you have 2. It's not a recessive gene, and albinism is a great example of a recessive gene in clownfish, where you must have 2 copies to express, to see that the fish is an albino. If it has 1 copy, if it's heterozygous, then it looks outwardly like a normal fish. We might call it a het for short. Het for albino. It has 1 copy of that albino gene hidden, and it looks no different than a fish that has no copies of the gene. So that's where Ocellaris clownfish have kind of gone. And the most recent leap into all that is something called frostbite. And frostbite, very simply put, is a Ocellaris clownfish that has both a copy of the Snowflake gene and a copy of the Da Vinci gene. Has both of these genes, and when you put both of these genes together, you get a fish that, generally speaking, is almost solid white and has varying amounts of black spotting in it. That is a frostbite Ocellaris. It has 2 designer genes, 2 mutant genes, and that's how that appearance, that phenotype, manifests itself. So that's Ocellaris in its pure species. I'm sure I'm forgetting something. But you also raised the black ice and black snowflakes. And that's another story, because it goes back to what a black Ocellaris is. And I hinted at it earlier, which is black Ocellaris comes from Darwin, Australia. It's only found in Darwin, Australia. And in talking with collectors in Darwin, there are no orange Ocellaris in Darwin. They are all black. For other reasons that I'll just briefly touch on, I believe it's a separate species, biogeographically isolated from all the other populations of Ocellaris, in the same way that several other species are also isolated from sister species that occur in the Indo-Pacific. A really good example is the aforementioned Amphiprion rubrocinctus, which is the Australian ruby clownfish. It basically looks a lot like a tomato clownfish. There are subtle differences, but the easiest way you would know you got a rubrocinctus is not by looking at it, but by knowing it came from, it was collected on the northern shore of Australia and not somewhere like the Philippines. So in the same way that those species are separated, so too the Darwin Ocellaris, the black Darwin Ocellaris, is isolated and separated from all the other orange Ocellaris that occur. So while current taxonomy considers them to be the same species, pragmatically, I do not believe they are. As a breeder, I do not believe they are. They also happen to behave differently, have different times to sexual maturity. There are many, many little subtle pieces of the puzzle that when you start looking at them all together, we kind of say these can't be the same species of fish. Whether taxonomy ever jumps in and agrees with us or not is up to the scientists who determine whether they're going to even bother looking at the question, are they the same species or not? But this is where it all becomes important, because the black ocellaris only has one or maybe two genes that have occurred in known populations that are pure. That is to say, the zombie albino is a mutation that showed up in a pair of ocellaris that have been in captivity so long that they only could have come from and been derived from wild-caught original fish from Darwin, Australia. There is also a long-fin black ocellaris, and as far as we know, that arose independently of the long-fin ocellaris. And interestingly, they occurred about 4 months, 5 months apart. So there wasn't even enough time for them to get an ocellaris and somehow put the gene into black ocellaris and get it. It just happened spontaneously in two independent settings, in two different groups of clownfish. But to create a black ice, what a black ice is, it's the first generation hybrid offspring of a snowflake ocellaris with a Darwin black ocellaris. So you basically have two things occurring. You have the snowflake gene in that snowflake ocellaris being given to half of the offspring. And you also have, independent of the gene, an orange ocellaris and the Darwin black ocellaris coming together. And when they come together, the result is something you call a mocha. It's a very outwardly recognizable hybrid, in my opinion. It is a blending of the two traits. The fish that are mochas look neither like the pure black ocellaris or their pure orange parent. So any of the offspring that have regular three bars are mochas, and then any of the offspring that inherited that snowflake gene are what we now call a black ice. And I should note, it was actually named the s'more clownfish first, but larger companies with bigger marketing footprints went with black ice, and so now we all call it black ice. That was the first generation of breeding that brought these two species together. And I'm using the term species, although taxonomy would not consider that species. So to be technically correct, we would call it an intraspecies hybrid, a hybrid within two distinct groups within a species. And there are many examples of what could be interspecific hybrids, but it is not taxonomically two separate species. In my opinion, it's two separate species. That's the first, but the ultimate goal, and the reason that was done, was to create a black snowflake. So breeders have taken the black ice and they've mated it back to Darwin black ocellaris. And out of that, you get what we call blacker ice and chocolate mocha. Taking those blacker ice and mating them back to a black ocellaris again is pretty much where I think we got to the point where we started to have pure black fish with the snowflake gene. But you also get pure black fish that do not have the snowflake gene, and outwardly, they look no different than a pure Darwin black ocellaris. Pragmatically and for conservation purposes, however, those are not black ocellaris, but they get passed into the trade as black ocellaris. So all of a sudden, we've seen through we want to aspire to some goal of a black snowflake. We've blurred the lines between these two species in captivity to the detriment of the Darwin black ocellaris. And the real problem right now is you cannot go get wild black ocellaris anymore. They're not being collected. I'm not saying they're not there, but you cannot go get pure known Darwin black ocellaris in the trade at this time, and you haven't been able to for quite some time. So now, if you want to have that conservation ethic about your breeding, and I think everyone should, you really have to do your homework to find out if the black ocellaris being sold to you is actually something pure or if it's something that has ocellaris genes in it. And so that's kind of a good example of how hybridization can cause a problem in the aquarium trade as it pertains to being a good steward of the species we keep.
Well, thanks for that really great explanation. We're out of time, unfortunately, but before we finish up, I did want you, if you can maybe just for a minute or so, describe the lightning work that you've been working on and how the fish looks appearance-wise, because I think they're pretty actually beautiful.
And lightning is a wild-caught fish. It started with a single wild-caught fish that was found in Papua New Guinea. And it was through a lot of back-channel discussions and talking, it wound up coming to me. And I was chosen as the breeder to work with the fish. To describe it, it basically looks like a maroon clownfish. And I think most people know a maroon clownfish is a big clownfish shaped like an ocellaris. I mentioned it has a spine under the eye. Its base body color is a wine red. It's a maroon kind of looking color. And it has white stripes. This is Premnus biaculeatus. There is also a gold stripe maroon, which carries a name that half of the world doesn't use. That's Premnus epigrammata. Again, a case of two species that I think are two species, but currently recognized as one species. So the white striped maroon clownfish from Papua New Guinea is where the lightning gene originated. And what the lightning gene does to a maroon clownfish is it causes what I like to lump together. It's another one of these overbarring traits. It changes something about the way bars develop on a fish, and it makes more bars than there would normally be and does interesting things. And so a lightning maroon, the wild fish basically looked like it had white netting draped over its body, or if you prefer, lightning bolts fingering and splitting off, or the roots of a tree coming over the flank of the fish. And it's on the head stripe was more irregularly shaped and full of little red dots, and the tail stripe was also broken up with this lightning patterning. What we know now from my breeding is that it is probably a dominant gene in the same vein as how I describe snowflake working, which means a lightning crossed with a regular PNG white stripe gives you 50% lightnings and 50% regular three-stripe clownfish. That's the Lightning Maroon project. Unfortunately, some people have taken it upon themselves to say, well, if we can have a lightning, let's also make a gold lightning. Unfortunately, it goes back to that same situation that just played out with the Darwin ocellaris. And what's going to happen now is people are hybridizing the gold stripe maroon with the white stripe maroon to put that lightning gene into gold stripe. And the unfortunate side effect is you cannot tell what a gold stripe is versus a white stripe for a year anyways, because as juveniles, they all have white stripes. Gold stripes only reveal themselves in maturity. Gold stripe clownfish, gold stripe maroons come from the Indian Ocean. White stripe maroons come from the Pacific Ocean. They come from different oceans. And unfortunately, people are mixing them together. And the problem being, again, we will lose the purity of these two unique and wonderful species in the trade if people pursue this avenue. But it's being done. If I can be so bold as to say, please do not buy these gold lightning maroons. That's my stance. Be an active participant in promoting conservation. There was nothing wrong with the lightning maroon. We didn't need to make it better by turning the stripes yellow. And I'll rest my piece there.
Well, unfortunately, we are out of time. I really appreciate all your knowledge and your great explanations into a fairly complex subject, but, really a beautiful subject. These varieties are pretty fascinating. We'll work on getting some of your pictures on the blog. Thanks again to my guest, Matt Peterson, and our producer, Mark Winter, for making this show possible. Any final words of wisdom, Matt, for our listeners?
Well, we really didn't even touch on the natural biodiversity of clownfishes. We mentioned at the start that there's 30 species, but in reality, if I'm a splitter, there's probably something closer to 40, maybe even 50 species of clownfish out there. Clarkie clownfish alone have at least 11 known variants. So for all the people who want a fish that's a little bit different, because that's how it's going with the designer fish, we really need to, I think, refocus our attention back on the natural biodiversity that the world has already provided. So I would say go check out my articles on the amazing biodiversity of clownfishes, and that geographic diversity is just something else that most people don't even know exists.
Thanks very much for that. And thanks again for joining us, Matt. Please be sure to check out Matt's webpage links on Aquariumania, as well as the latest Coral magazine. I encourage all of you to visit my Aquariumania blog on Pet Life Radio. Also, if you have any questions, comments, or ideas for a show, please email me at drroy@petliferadio.com. That's DRROY at petliferadio.com. Until next time, please visit your local aquarium stores and keep your tanks clean and your fish healthy. And keep an eye out for Designer Clownfish and Reef to Rainforest Coral magazine.
Let's Talk Pets, every week on demand, only on PetLifeRadio.com.